Everybody, we're going to go through activities 4.3 and 4.4 in this video. First one for 4.3, you got to analyze a table. It gives you the number of windows and the amount of window cleaner used. So if you don't clean any windows, you don't use any cleaner. You clean 2 windows, or you have 2 windows to clean, you use 16 ounces of cleaner. 3 windows, 24. 4 windows, 32. All right? So basically, describe one possible situation that could be represented by this table, and the values include how the quantities relate to one another. So my whole thing was like, I'm thinking like, all right, if I'm a window cleaner, how much cleaner do I have to bring to my job, right? I'm going to a building, I got to clean some windows, I got to know how much to bring. I don't want to carry too much, but I don't want to be short. I'd hate to be up like high cleaning a window and then run out of cleaner, right? So I need to know how much I should bring. So the amount of cleaner should equal the constant, or the amount of cleaner needed, times the number of windows. So the total number of cleaner equals cleaner per window times the number of windows, okay? Your job for this one is going to be to find out what that constant is using this this chart up here. And I went ahead and added a total cleaner used over the number of windows column for you to figure out what the constant of proportionality is. Tell me what it means, and then a table. If the table were used to create a graph, how would the points appear? That means I want you to use words like linear or nonlinear. I want you to use starts on the y-axis, starts at the origin, anything that you can think of to describe how a graph would look. All right, your next part for this video is on 4.4. I'm going to go through problems 1, 2, and 3, and then you're going to do problems 4, 5, and 6. Okay. So let's look at 1, 2, and 3 together. A baby elephant nurses for the first 2 years of its life, and it drinks 10 liters of milk per day. Define the variables and write an equation to represent the relationship between the amounts of milk the baby elephant consumes and the time it spends consuming the milk. So what is the total amount of milk that the baby's drinking over the 2 years that it nurses from its mother? So M would be total milk consumed, D would equal days old, and the constant would be constant in proportionality. In this case, our constant proportionality, K, is going to equal 10 liters per day, because we know that that is the rate of the amount of milk that the baby elephant's going to drink, okay? So once we've identified the constant of proportionality, the 10 liters per milk drank every day, we can kind of get an idea what this problem's all about, right? So we're looking, we know that a baby drinks 10 liters per day. We know that it nurses for the first 2 years. We can kind of create a graph based off that. So let's get that zoomed in here. Now I went ahead and labeled this graph. I put days as my independent variable because days are going to be independent. The days go on as the baby drinks. We were supposed to assume that it has the same amount of consumption over the 2 years, so that the total amount of milk consumed is going to be at a rate of 10 liters every day. So I made my y-axis every 10. And it says, create a graph. If the baby hasn't been born, it doesn't drink. 0 is 0. Day 1, 10. Day 2, 20. Day 3, 30. Day 4, 40. Day 5, 50. And we can go all the way out here to day 20 is 200. And then I can just go ahead and take this piece of paper here and create my straight line and show proportionality, right? We're starting at the 0. We're creating a linear relationship, and we can use this. It's continuous because at a half a day, he could drink half. At a quarter of the day, he could have drank quarter. It's not discrete, so it's going to be a continuous line, all right? So your job now is going to be to go ahead and do the next problem and do the same 3 types of questions.